Hello. Today we're going to go over the exponent notes on page 21 in your packet. Alright, so first we're going to just go ahead and break down what it's called when we see this. Okay, that is called the power. Alright, now the power can be broken into two things, the base and the exponent. So the base is 3 and the exponent is 5. And we read this as 3 to the 5th power. Okay, now the exponent tells us how many times to write the number 3. So that is the exponent of 5. So we're going to write this 3 5 times. 1, 2, 3, 4, 5. And as you see, every time I write down another 3, I put a multiplication symbol in between there. Okay, 5 3s, 4 multiplication symbols. Right, now if we had to do this longhand, it would look something like 3 times 3 is 9 times 3 times 3 times 3. 9 times 3 is 27 times 3 times 3. And also 27 times 3 is 81. And 3 times 81 is 243. That would be our answer. Luckily, we have these things called calculators. Now, if you have your calculator handy, you will see if I can get that in the right place. I believe that looks good. So we're going to go with 3 to the 5th power. So we're first going to put in the base. If that registers. No. There we go. It worked for me. Alright, first we're going to put in the base. Then we're going to go to the button above the division sign. Alright, so y to the x power. You put in the y first. When you hit the yx button, you're then telling the calculator I want to fill in my exponent. So we're going to hit 5. Then we hit enter. Voila. Same thing. 243. 243. And look at that. We didn't have to do a lot of work. The most important thing is to understand the keystrokes. So put in the base first. 3. YX. And then 5. You get 243. Alright. Now that we have that down, we're going to go through the rest of this worksheet. Okay. Now things to note here. Alright. If you have a power to the second power, we call that squared. Okay. So this is 3 squared. This is 6 squared. This is 8 squared. Alright. Then we have 3 cubed. This is 9 cubed. Okay. This is 14 cubed. This is 15 cubed. Alright, now we have a couple of different rules that go along with exponents. Just a way to, if you see these during a problem, you can kind of take some of the work away for yourself. Alright, any number raised to the first power is simply that number. Okay, so 100 to the first power is 100. 10 to the first power equals 10. And 9 to the first power equals 9. Alright, our next rule is any number raised to 0 equals 1. So look at this. 12,345 to the 0 power equals 1. Alright, and there's 1 with exception, which is 0 to the 0 power, and that's undefined. Okay, so now let's see if we had 4 to the 0 power. That's going to equal 1. What if we had negative 4 to 0 power? What would that be? Right? Negative 4 to 0 power, that would equal 1. There we go. Alright, so let's move on. I put those parentheses there because that can open up another can of worms, which we will get to later. Okay. Alright, so now let's go down here. Any raised to the power, any number for the power of 1 is still going to give you 1. So 1 to the 5th power is 1, and 1 to the 234th power is going to be 1. Then it looks something like this. 1 times 1 times 1 times 1 times 1. Right? That's 5 ones, and 1 times 1 is 1, 1 times 1 is 1, and you get it so on and so forth. Okay, now we have parentheses. The parentheses help us out because they help the exponent see everything inside the parentheses. Okay, so that's going to come back, that concept will come back first. But now this here, this part of the parentheses, we're going to follow Jim does. So orders of operations thing. Alright, so this G stands for grouping and this E stands for exponents. So the G simply states that we have to do what's inside the grouping before we can simplify the exponents. So as you see here, -2 times 6 is -12. Look, we didn't mess with the exponent. Now that everything inside the expression or the grouping symbol is simplified, we go ahead and we execute the power. -12 squared is 144. Alright, now the next concept is any number raised to a negative power makes you flip the numerator into the denominator. So the 2 to the negative third power simply becomes 1 over 2 to the third power. Where's that 1 come from? Under every number, right, is an imaginary 1. So that 1 goes to the top, and the 2 to the third power goes to the bottom. Now that negative becomes a positive. Okay, and now we can execute. We cannot execute negative powers. We have to make them positive first. To make them positive, they have got to go through this division line here. Once they go through the division line, they are now positive. Now you can execute them. 2 times 2 times 2 equals 8, or come over here and we have 2yx3 equals 8. There you go, works out fine. Alright, now let's do some practice. So this 2 to the negative fourth power, alright, remember I said the parentheses help us to see everything inside of them. So this is -4. This is simply -4 times -4. Alright, and that's going to give you 16. Now this here, this 2 does not see this negative because it's not inside the parentheses. It's outside the parentheses, so the 2 stops here. Right, that's what that looks like. 4 squared. 4 squared is 16, so you write 16, and then you just bring the negative down. And now that's -16. So if that negative is not inside of the parentheses, it's outside or there are no parentheses, leave it alone and just bring it down. It's also telling you take the opposite of that answer. Okay, and we just saw our rule. Any number to the power of 0 is, yes, it's 1. A number to the first power, this is another rule we just learned, is that number. So a base to a first power is the base, and that's going to give us 100. Alright, this is another rule. These are all the rules, okay? 1 to any power is going to be 1. Good job. Alright, let's move on over here. Okay, we encountered our first negative exponent. Remember, the negative exponent told us to simply go through the division bar. Okay, so now we can draw a division bar underneath that. We can draw 1 down here, and we can flip it. So now it's going to be 1 over 4 to the third power. And then that's going to be 1 over 64. 1 over 64 is going to be a correct answer. You can put this in your calculator and get a decimal, right? So first let's do 1 divided by 64. Look at that, it gave us 0.15625. Now let's do 4 y to the third power 3 negative, enter. Same number, 0.015625. Same exact number. So if we're on a test or if we're on a quiz and it only asks for the decimal, that's a good way of doing it. But a lot of the times you'll see that they want the fraction. So you have to understand the concept that a negative exponent cannot be executed. It must first be turned positive. To be turned positive, it must go through the division line. Okay? Every whole number has a number 1 underneath. So we simply flip it, right? Denominator goes to the numerator goes to the denominator. Denominator goes to the numerator. And that's how we come over here. And now we simply execute it. 4 to the third power is 64. And if we want the decimal, we could go ahead and find the decimal. But most of the times, they're only going to be asking for the fraction because they want to know that you understand the concept. This here, the 3 can see the -1 because of the parentheses. Yes, so this is -1 times -1 times -1. Like I've said in class, when you are multiplying and you want to know a quick way to see if the answer is going to be negative or positive, you can simply look at how many negative signs there are. If there are an odd number of negative signs, the answer is going to be negative. If it's an even number, it's going to be positive. So let's count it up. 1, 2, 3, 3. So that's going to be odd. So the answer is going to be -1. Negative times a negative is positive. A positive times a negative is negative. So that's how we justify our answer, -1. Parentheses. Think about orders of operations. G before E, so grouping. So 4 times, -4 times 2 gives you -8. -8 squared gives you what? -8 times -8, which equals 64. Alright, here we have a negative times a negative, which is going to give us a positive, so we're going to have 6 cubed. Let's put that in our calculator. 6 cubed. 216. And the last one here, remember we said that this exponent cannot see anything outside the parentheses. So can it see this negative sign here? No, it cannot. We're just going to drop the negative sign to the bottom. Now we have -5 squared. So we're going to do 5 squared. 5yx to 25. And we're just going to drop the 25 after that to make sure it's a -25. Alright, and there are your exponent notes.